This video looks at calculating the density for irregular shaped objects. This is an irregularly shaped stone, and we've got this bung that would be quite difficult. We probably could calculate the volume, made a bit harder by these holes going through the middle, but we would describe that as an irregular shape. And we've got this thing here called a Eureka can, and famously named after Archimedes sat in the bath and the water went over the top of the bath and he had that eureka moment, shouted eureka, and the can was named after him, or after the word he said. You can see it's got this upside down spout. It's kind of pouring out, sloping downwards here, and we're going to fill this on the edge of the table using some water. I'm just going to put my thumb over the spout and pour that water in so it goes up and over where the spout is. And then I'm going to put my beaker underneath. Oh, maybe I need to put a bit more in. Put my beaker underneath to remove any excess water. And then I need to look at my object. Okay, so we're using this equation that you might have seen on the regular shaped density calculation video, where we've got density is mass divided by volume. Okay, mass we can work out the same way, just pop it onto the scales, and this is how we're going to find out the volume of the object. So we have the knowledge that 1 milliliter is, I don't know if I said millimeter there or milliliter. Anyway, 1 milliliter is the same as 1 cubic centimetre. Okay, so 1 centimetre cubed. Okay, and I've got to look at my object and decide what is the most appropriate measuring cylinder. I think that one's probably too small to collect the amount of water this is going to displace. If I look at this one, it might be tight, so I think I'm going to go for my larger measuring cylinder so I don't overflow with water. So I'm going to place my measuring cylinder underneath and slowly lower my stone in. As you can see, it's sending that water through the spout. If I just drop it, it's going to splash everywhere, so gently does it. And there we go. So if I put that on the table and have a look at eye level, so I'm getting down low to have a look at this, and I can see that is exactly 30 millilitres. Okay, so the volume is 30 centimetres cubed. So stone, the volume, which is what I'm going to divide by, is 30. Okay. So I now need to take the stone out of the Eureka can, which obviously putting my fingers in means I'm going to spill some more water. So I've got my beaker there to collect it, and then dry that stone off with a paper towel. And give it away. Okay. And that is 79.33. Okay, so use my calculator. 79.33 divided by 30 gives me 2.64, and I keep it as 6.4 because this 4 is lower than this 4. Okay, so I'm going to write 2.64, and that is grams per centimetre cubed. Okay, I'm going to do my second object now, which is my bung. And to do that, I'm going to do exactly the same process. Thumb over the spout there, pour my water in and drain any excess. Okay. And then I think again I'm probably going to need the larger measuring cylinder because it's quite a large object. I think if I went for the 25 ml, I think probably it's going to overflow. So I'm going to drain out all the water from there, hold this underneath the Eureka can and slowly lower my object in. There we go. Don't want to allow it to overflow over the top by putting the object in too quickly. And then down at eye level, and that is 46 millilitres. So this is the bung, and it's 46 millilitres, which means 46 centimetres cubed or cubic centimetres. And then we'll take the stone off here. Might have been a better idea, I suppose, in retrospect, to have weighed it first. Then wouldn't have to dry it so carefully. Something to bear in mind. But I'm sure I can cope. Give that a good dry. Onto the scales. Check the scales are on 0. And that is 64.95. 64.95 into my calculator. 64.95 divided by 46 gives me 1.41. 0.41 grams per centimetre cubed. Okay, so we can see that the stone is much denser than the bung. Move that out of the way. Okay, hope you found that useful. Thank you.